Hey there, and welcome to my channel dedicated to retro programming on the Commodore 64. And today I would like to talk about mapping the Commodore 64 and 64C by Sheldon Lehman. A book initially published in 1984 and then republished in 1987, and that's the edition you're seeing right now on the screen. It's a masterpiece, actually. It's a great book. It's a book you should have if you wish to program the Commodore 64 in machine language assembly. This book is great, but it contains a few mistakes and errors, and let's track them down. Okay. Well, here's the first one I found. It's here on address 61 in hexadecimal. It says that an exponent of 128 is used for the value of 0. It's not really clear if it means it's used for the value 0 itself, which would be incorrect. Actually, 0 is the value used for 0. But if it's referring to the exponent, it's correct. But then it says an exponent of 129 represents 2 to the power of 0. Not really. If 128 is used for the value 0, for an exponent of value 0, then it cannot be 129. Actually, 129 represents 2 to the power of 1, and an exponent of 130 represents 2 to the power of 2, not the first power, etc., etc. Well, second mistake, well, actually it's not a mistake, it's more a typo tracked down, and it's here. As you may see, this is the name of the line, what we call the label. The label is charge get, and then you can see that it says charge got LDA. Actually, charge got is the name of the line, it's the label. So, well, charge got should be moved here to the left, should not stay there. Okay, here's another typo. Well, as you may already know or have noticed, addresses of the memory are written in decimal here and hexadecimal here. Well, as you may see, here it says that the pointer starts at the address 281 to 282, and then it says that this other pointer starts at 282 and to 284. It cannot be 282, it's 283. There is also a typo here on page 73. You may read at power on, the CIA number 1 timer B is said to cause an IRQ interrupt to occur every 1 to 60 seconds. Well, it's not the timer B, actually, it's timer A. Another typo here on page 76. Now, well, actually two typos. This one, it says that the vector to the kernel load is 62,622. It's 62,929, and the hexadecimal is F4A5. Well, the typo here, there's another typo. It's here. It says that the kernel save routine vector is at 62,941, it's 62,957, and in hexadecimal it's F5ED. Decimal and hexadecimal are sometimes confusing, and you may see another example here on page 103. It's here. It says that well, the check for and skip comma address starts at 44,799. Actually, it's 44,797. And the equivalent in hexadecimal is AEFD. Well, I don't know if you're familiar with floating numbers and what we call the mantissa, but the kernel contains some routines which helps you to use to do operations with floating numbers. This is the case of this routine mentioned here. Multiply fact1 by value in memory. It says that well, the routine is located here on hexadecimal BA28. Actually, it's BA30. But if the number in fact1 is 0, you won't get a 0 actually for the result, which is a bit weird. You will get a very small number. Well, the proper way to use the multiply routine, which multiplies fact1 by fact2, well, is to call a routine at the address BA2B. You must put FF, the value FF in hexadecimal, into the address located at 6F in hexadecimal if the signs of the two numbers are the same. But you have to put 0 into 6F if they are different. And also the Z or Z flag must reflect the exponent of fact1 at address 61 in hexadecimal. You just need to do an LDA 61 right before calling the routine at BA2B for that purpose. Another mantissa and floating point number issue. It says here at the address 48,563 in decimal that this table of 3 floating points constants holds the values and so on. These values are used in converting strings to floating point numbers. Okay, so if there are 3 floating point constants, they are comprised of 5 bytes. 3 multiplied by 5 gives 15. If you add 15 to this address, well, you don't get 40,576. 15 plus 48,563 gives 48,578, which gives in hexadecimal BDC2. Okay, here, well, again, some typos here about the CIA control registers. Well, actually, it says about the bit 5 that timer A input mode 1 will count microprocessor cycles, and 0 will count signals on CNT line at pin 4 of user port. Well, there's an inversion. Actually, it should say here 0 and here 1. and you'll find the same error here. Well, about bit 7, you have to invert the references. It says 0 will write to the time of the day registers, sets alarm, but actually it's 1 which will set the alarm, and 0 here will write to the register to set the clock. Well, same remark about addresses 56,590 and 56,591, which are the the registers for the CIA2. You see the same error here about bit 5. It should write 0 will count the microprocessor cycles, and 1 will count the signals on CNT line at pin 4 of user port. And here, about bit 7, it should write 1 will write to TOD, time of the day registers, and set the alarm. And here it should say that 0 will write to the time of the day registers to set the clock. Now about the read set location of the cursor at the address 58,634. You can read that that the Y and X registers are loaded with the desired row and column positions respectively. Well, actually it should be inverted. It should read the desired column and row positions respectively. And now, last but not least, actually it's not a mistake or a typo, it's more something that should have been specified, which is not specified actually in the programmer's reference book, but it is specified in a book called the VIC-20 and Commodore 64 Toolkit kernel, published by Compute Editions. It's here about the second routine. Well, it says that this is documented kernel routine that can be entered from the jump table at 65,427 in hexadecimal. It is FF93. It sends a secondary address from the accumulator to the device on the serial bus that has just been commanded to listen. Well, actually, you have to perform an instruction. Before that, you have to do an ORA with the value 60 in hexadecimal. Actually, if you put the accumulator directly, it won't work. And you find, and this is valid, my comment is valid here for the routine called talk TKSA at the address 60,871. It says that it sends a secondary address from the accumulator to the device on the serial bus that has just been commanded to talk. Actually, it's the accumulator ORA'd with the ORA and value 60 in hexadecimal. Again, if you put the accumulator, if you load the accumulator and you use this routine, it won't work. You have to perform this prior operation with ORA and the value 60 in hexadecimal. Well, guys, my video is over. Hope you enjoyed it. And if you found any other mistakes, errors, errata in this book, well, it's time to mention them in the comment section. and see you soon.